Hey guys, Miss Terrell here. Today we're looking at Algebra 2.4 solving proportions. Our essential question, how do you solve a proportion? So a quick review. We have two rectangles here. The first one is divided into 3 parts. The second one is divided into 6 parts. Notice that the rectangles are the exact same size, just divided into different number of spaces. In the top rectangle, we have shaded 1 out of the 3 rectangles. In the bottom one, they have shaded 2 rectangles out of 6. So you can tell visually that these two sections take up the exact same amount of space. So we can say that 1 out of 3 is the same as 2 out of 6. Since these ratios are the same, they are in proportion. So this expression right here, this is called a proportion. You also can notice that 1/3 equals 2/6. Well, if we reduce this fraction over here, 2/6, that reduces to 1/3. Now, I want you to notice something else. What happens when you cross multiply? To cross multiply means you take a number in the numerator, go across the equals, and multiply it by the number in the denominator. So here we have 1 times 6. And then when you go across the equals in this direction, from the denominator to the numerator, you have 2 times 3. Notice that when you multiply this, you get 6, and on this side, 2 times 3 is also equal to 6. So whenever you have a true proportion, the cross products, the numbers you get when you multiply across the equals, are always going to be the same. Example 1. Mr. Gervin can run 5 miles in 32 minutes. If he continues at this pace, how long will it take him to run 12 miles? The key here is that he continues at the same pace. That means the ratio, the rate at which he's traveling is going to stay the same, so we can compare the number of miles run with how many minutes it takes him to run. So what we're given is this first ratio here. For every 5 miles he runs, it takes 32 minutes. Then it says, how long will it take him to run 12 miles? All right, how long? We don't know how long, how many minutes. So that's going to have to go in the denominator. We know that he's traveling 12 miles. So if I start with miles in the numerator, I need to keep miles in the numerator over here. So once you have your proportion set up, then you're ready to solve by cross multiplying. So here we're going to multiply 5 times x, and we're going to multiply across the equals here. 32 times 12, that should give you 384. So here you have 5x equals equals 384, and we want to solve that, so we're going to divide both sides by 5. And then you are going to get 76.8. And in this case, remember we are talking about how many minutes to run. So it's going to take him, 1 hour would be 60 minutes. So approximately 1 hour and 16.8. So about 1 hour and 17 minutes to go 12 miles. Now, Mr. Gervin, he's one of the cross-country coaches. He ran in high school. He is a speed demon. I'm not going to tell you my pace because, hey, I'm out there running anyway. Not as fast as Mr. Gervin. Let's just put it that way. All right, look who showed up today. Miss Hoover. Now, we were at the vet this week because Hoover's getting quite old. Hoover is 17. The vet says when we get up to this age, they like to think of the ratio that 1 year for dogs, 1 year for a dog, is the same as 5 years for humans. So let's say we know that Hoover is 17 years old. So how many years is that in human years? So I would have to put an x in the denominator to solve this. Now look at this. We're going to cross multiply. 1 times x is x. And then over here we have 17 times 5. 17 times 5 is 105 years. So Miss Sweet Hoover is approximately 105 years old in human years. And look at that sweet face. Have you ever seen anything so quick? She has little horns up here. Interesting little features as you get older. But her hips are getting pretty worn out, but man, she is one sweet little puppy. All right, let's move on. Let's look at some other examples here. We are going to solve 2 over 5 is equal to 4 over n plus 5. Our strategy here, whenever you see a proportion, is to cross multiply. Now, I do want to point out one thing. Right here, this proportion, this 2 over 5, can be reduced. So if you want to save yourself some work, you can reduce any fractions before you cross multiply. So I think I'm going to do that. 2 over 10, well, that reduces to 1 over 5. So 1 over 5 is equal to 4 over n plus 5. Whenever you have an expression that has 2 terms or more, you want to put that in parentheses. So right up here, make sure whenever you have an expression with more than one term, put it in parentheses, because when you cross multiply, that's going to be pretty important. Now in this one, since I simplified first, it doesn't really matter. So I have 1 times n plus 5 is equal to 5 times 4. 5 times 4 is 20. When you have that 1 out in front, well, that doesn't really change anything because 1 times n is n. 1 times 5 is 5. And then subtracting 5 from both sides. So the value of n is 15. Our final answer is 15. Now, you can always check this, just like all our other problems. If I plug in 15 up here, I would get 4 divided by, let's see, n is 15. 15 plus 5 is 20. Does that reduce to 2 over 10? Yes. And both of them reduce to 1 over 5. All right, so we know this is correct. Example 3. Solve the proportion 2k minus 3 over k plus 9 is equal to 3 plus 5. Before I do this, what did I remind you in the last example? What do you have to do? First off, when you have those expressions with more than one number. All right, I hope you said that you need to put some parentheses in here. I need to put these in parentheses so that when I cross multiply, I remember I have to distribute. So let's look at this. I'm going to cross multiply this way. I'm going to put my 5 out in front of the parentheses 2k minus 3 is equal to, right, when I look at these two numbers across the equals, I like to write my constant in front. So you have 3 parentheses k plus 9. If you write it on the other side, you still have to distribute, okay? So I just like to have it look like I'm used to seeing it with the constant out in front. So what do we have to do with this number? Y'all are getting really good at distributing. Remember those arrows to remind us we need to go to both numbers. So starting with the 5, we're going to multiply 5 times 2k. 5 times 2k, 10k. 5 times, make sure you include the sign, 5 times negative 3. What's 5 times negative 3? That would be negative 15. All right, bring down the equals. Now we need to multiply the 3 times both of the numbers on the inside. This time we have a positive 9. So 3 times k. 3 times k would give you 3k. 3 times positive 9 would give you a positive 27. We're back to an equation where you have variables on both sides. There's nothing else to simplify here. There's no like terms on the left. We can't add those. And on the right, there's no like terms over here. So what are we going to do? We've got to get your variables on one side and your constants on the other side. Let's see, we have 10k over here on the left. So I want to move the 3k over to the left. So I'm going to subtract 3k from both sides. 10k minus 3k, 7k. Bring down your negative 15. Bring down the equals. 3k minus 3k, that would be 0. We don't need to write that down. 0 plus 27, just 27. Continuing to solve, we're going to add 15 to both sides. Draw my line here, keep it nice and organized. I'm going to bring down that 7k, negative 15, positive 15, that's out of there. 27 plus 15, that would give you 42. Now, the last step, we're going to divide both sides by 7. So we get k is equal to 42 divided by 7. That is one of the hardest multiplication facts for people to remember, I feel like. 42 divided by 7 is 6. All right, so that wraps up. I just did a couple examples because we've already practiced solving with variables on both sides. So I didn't want to just bore you with too many examples there. So let's move to the next slide and see what's going on here. The problems on the back of your note sheet, the U-try problems. It says solve each proportion for the variable, check your answer, don't forget to put the expression in parentheses. You can save 1 and 2 to do in class next time. I would like you to start with number 3 and solve. I'm going to help you set it up to start with. I want you to solve 3, 4, 5, and 6. I'm going to ask you to actually put the answers in your Ed Puzzle video so I can give you some feedback on those. So let's go ahead and set up number 3. W minus 2 divided by W equals 3 over 6. We're going to start with putting that expression in parentheses. Do you see a little shortcut that we could do here? 3 over 6. What is 3 over 6 reduced to? Bob, what is 3 over 6 reduced to? F. Very nice, thank you. All right, so we have W minus 2 over W equals 1/2. We're going to cross multiply. So I'm going to put that 2 out in front. 2 parentheses. W minus 2 is equal to 1 times W. I'm going to let you solve it from here. Remember, you can always plug it back in to check it. You're going to put your final answer in the Ed Puzzle video. Number 4. When you're evaluating, I'm going to do one little review up here. If I have negative 5 and I square that, remember that you're multiplying a negative 5 times a negative 5. So your answer will be positive. So make sure when you're evaluating, you put those negatives in parentheses. Number 5 says if Sue is S years old, write an expression for double Sue's age increased by 6. You're given that Sue is S years old, so write the expression for that. Number 6, you're just simplifying by combining like terms. Now, remember what we talked about in class for like terms. Let's look for box and circle. Box and circle your terms to help you get the right answer. I hope you took amazing notes like you've been doing. Keep up the good work, and we'll see you next time in class.